And today we are to discuss about data and basic programming. Data and basic programming. You see, in this entire course, our focus is to be able to analyze data so that at the end of the day, we are able to come up with some insights, or rather be able to make some conclusion from that particular analysis. So we have the data. Now we use this programming language to do the analysis. So we realize it is important to first understand the concept of data. What type of data do I have? And all that. Then now understand the programming aspect of how you can create some functions that now can do the analysis. So I want us to start by discussing data types. Now, I know this is not the first time we are discussing this, more so in this class. All us here, we have some basics in programming. So they are the same data types we have been talking about. So R has a number of basic data types as well, and one of them is the numeric. You know, we have the numeric as the first data type. It's also known as double in R. And you realize it will always be the default data type whenever we are dealing with numbers in R. So for instance, when I write the number 1, R will take it as a numeric value. When I write 4.52, R will take that as a numeric. So that is one of the data types. So the first data type we are saying is the numeric. Saying the first data type is the numeric, and an example is 1, 4.5, and let's say 7.0. So that is one of the data types. Numeric. Another one is integer. We also have integer. We all know that integer is a whole directed number. Integer. So integer is also kind of numeric, but now at times you realize there are other values that will also be considered to be numeric. Like for instance, 2L. 2L will be considered to be, an integer. Maybe L represents meters and all that. So that is another data type. Now another one that is in the concept of mathematics is what we call the numeric. The complex numbers. I'm sure you have heard about complex numbers. So we also have this in R as a data type. So let's say you have 3, where 3 represents the real number. Then we have the imaginary part represented by an I. And I is nothing but the square root of -1. So that is also a data type in R, the complex number. Now another data type that we have is logical. I know this is also familiar with us. Logical, these will basically return, there are only 2 possible values for logical. That is true and false. So these are the logical values. And it's a data type. So you realize, at times you'll be trying to test maybe a certain aspect, and we're expecting to know if it is true or false. So in such a case, the logical data type will be applicable. Now another one that we all know is the famous character. Is also a data type. Now here is when now we have a word or rather string or character. From the word character, there are letters, so to speak. So Like characters we have, like let's say A. And now whenever you write characters, you need to put them in the quotation. And most preferable the double quotation. Like A is a letter. Like let's say I'm seeing Saif here. That is a name. So that is also a character. They are characters. So again, you realize at times when I write a number, let's say 3, but now I quote that. Now it will be taken as a character and not a value. So that I can't do operations like addition and subtraction with such a number. It's like a name. It's like a letter. So when I say 1 plus 2, or rather plus 3, there is also a word, like a sentence or something, but it doesn't really make sense in mathematical aspect because it's a character. So basically those are some of the data types that we are going to interact with as far as R programming is concerned, and many more that we will be able to discuss as we proceed. But most importantly, those are the ones that we'll be using now and then. Now, that is what we call the data types, the various data types that exist in R. And these are what we call the basic data types that we are will mostly deal with. Now, we want to go ahead and now discuss about what we call the data structure. Now, yes, we have the data type, but can we have a combination of different data types to make up a particular variable? That is the question. Or how are we defining this data in R? So basically, a data structure can be what we call homogeneous or heterogeneous. Now, a data structure, when we say a data structure is homogeneous, we mean all the elements in that data structure are of the same data type. So let's say, for instance, we have a variable. Remember when we were dealing with SPSS, I was saying a variable is like, now in the aspect there we were saying that a variable is like a question when we are doing some data collection in statistics as far as analysis is concerned. And we were saying a variable is like a question. So you go to that respondent and you ask, what is your age? So age is the question. Another person will say, I'm 21 years old. So 21 is the observation. Now, because we have, let's say, our target sample is, let's say, 30 individuals, at the end of the day, we will have 30 observations representing the age of the respondents. Now, you see, all those values that are there are all numerical. They are all numerics. So it's 20, 30, 25 of that age. So in such a case, we say that it is homogeneous. All the elements, all the observations are of the same data type. Now, in this context, we will say that a variable in R now and other programming languages, we will say a variable is a memory location where we store some information. So if I have age as my variable, I'm expecting it to store the various observations, or rather the recordings of the age of the respondents. They will be stored in the variable age. So if those elements, those observations are of the same data type, then that data structure, the variable, that age variable is said to be homogeneous. Now for heterogeneous is where now the elements can be of more than one data type. They can be of more than one data type. Like maybe we are just going there to record in the same column, maybe I record your first name, then down there the age. First name, down there the age. So I have Ali 22. Let's say now I'm getting names from here. Mary, I'm guessing this is random. Mary 20, Safe 23. You see, now I have name down there, I have the age in the same column, but at the back of my mind I know now this age, the name is for the particular person, and although that is not practical, but we are storing that information in one variable. So in such a case, we are saying that it is heterogeneous. It is heterogeneous. Now, we have different data structures in R that can actually accommodate variable of the same kind and not of different kind. Like not a combination. That is what I'm trying to say. As well, we have variables that can combine various data types to form one variable or even one data structure, so to speak. So a good example, that is what we want to focus at. A good example is what we call of homogeneous data structure include what we call the vectors, which are now one dimension. I hope in Form 2 we are doing vectors. It's just the same vectors. So the vectors are one dimension and they'll have the elements of the same data type. Another one is matrix. Now matrix is a two-dimensional. We all know that a matrix is a two-dimensional. And now it is also of the same data type. Again, we also have what we call arrays. Now arrays are more than 3 dimensions. Unlike matrices, arrays are more than 3 dimensions. But what is common for arrays, matrix, and vectors is that their data, or rather, those elements that are being stored there are always of the same data type. So, on the other hand, we have these what we call heterogeneous structures. Now, these are data structures which now can accommodate more than one data type. And a good example of this is what we call a data frame, which is two-dimensional. So our focus here on data structures will be looking at those which are homogeneous and also those which are heterogeneous. I hope to that point you are getting the difference. Now, if you do, allow me to just briefly talk about what we were mentioning about a variable. Now, a variable in this context of R, in most of the cases, we'll say it's a vector. Now, like yesterday, we were adding 3 numbers. When we were actually introducing R, we were saying we are adding 3 plus 2. And when we ran that, we were getting the answer as 5. Now, you realize at times, this value 3 is not used only once, but maybe is used several times again and again. Now, suppose we want to avoid the repetition of writing 3 and 2 all the time, but instead assign it to a value, or rather to a variable, so that it is stored, and whenever I need it, I just call the variable which now stores it. That is not what we call a variable. So variable basically is a memory location where a value or values are stored. So I can decide and say, let A represent the variable 3. So A is actually storing 3. Now, what we are doing, we are assigning a value to a variable. So the variable is A. The name of the variable is A. The value we want to assign is 3. Now the question is, how do we assign a value to a variable? Now to assign that, there are 2 options. You can use the equal sign. So I can say A is equals to 3. And I run that. mind you, in programming, we always terminate our statement or statement using a semicolon. But now here in R, it's not a must. It will always terminate for you. So there are two ways. I can use the equal sign, but in most of the cases, suppose now I want to assign B now to represent 2. Now in most of the cases, we will also use this operator. The less than or equal to sign is actually used as an assignment operator when it comes to R. So less than or equal to is just like equal to. But now using less than or equal to has more advantages than using an equal sign. I'll tell you why as we proceed. So I can say B is 2 and I run that. So instead of using the equal sign, I'm using the less than or equal to assign the value. Now I'll say I have another variable C, which is equal to the A now plus B. The A now plus B. Mind you, R is case sensitive. So capital B and small b will be treated as two different variables. So now when I run that, and now I call the value of C, you'll get that C is 5. So basically that is a variable. A is a variable that is storing 2, and B is a variable and is representing or rather storing, A is storing 3 and B is storing 2. Now I'm adding the 2 using and assign the sum now to a variable C. Now when I call C, it gives me the output. That is a variable. That is a variable. Now I want us, okay, let me just have a comment here and say this is a variable. Now I want us, okay, let me not bother about the spelling and such. Now I want us to look at the vectors. So let's look at the vectors, or rather vector. I'll have this as a comment, vector. Now we are saying that, oh, I really forget one important thing, but I'm sure it is okay with you. I was to check my working directory and then set my working directory. But that is always the first thing. But because we did that yesterday, I'm assuming you're opening it from where you saved yesterday. So it's still okay. Now, vector, a vector, like we are saying, is a collection of elements that are of the same data type. We said that vector is homogeneous in nature, storing elements of the same data type. Now, to create a vector in R, we use a function. We use a function, and this function is called the combine function. And this is the function C to represent combine and a bracket. So basically, what this function do is that it combines a list of elements separated by a comma, such that if I have elements 1, 2, 3, 4, 5, like that, they are separated by a comma, but on the last element, we are not putting a comma, of course. Now, this one will be combined together, so that we have 1, 2, 3, 4, 5 as different observations. This is now what we call the combine function, and it is the function that is used now to create a vector. So already there, when I run that, I have my vector. You can see here, when I run this command, it is giving me 1, 2, 3, 4, 5 as the observations. But now you see, we need to store this vector in a variable. That is why I started by talking about a variable. Now, to store this vector in a variable, we assign this now to a variable. And the best way to do that I can call this variable x. I can call this variable x, and then I assign it. So x is the elements 1, 2, 3, 4, 5 as various observations, and I run that. Now I have my vector x, and x is representing the observation 1, 2, 3, 4, 5. So when I run x, it will list the elements that are there in the vector x. You realize when you look at the environment here, the global environment, all those variables we have been creating are listed here. We have the variable, we created a variable a, and it is storing 3, b, 2, c, 5. X is storing these numbers 1 to 5, like that. So in the global environment, your variables will always be there. Your variable will always be there. Now, one thing that you need to take note is that the vector will always contain elements of the same data type, such that if I try to write elements of different data types, R will automatically make those elements of a single data type. Now realize, because vectors must contain elements of the same data type, now you realize if we try to write a vector that is of different data type, then R will automatically make it of one data type based on those elements. Like it will choose one of them and make it by default of that data type for all elements. This is what I'm saying. Suppose we have a vector, let's say I have a vector y, and now this vector y stores. Now the difference of a vector and a variable, you can say, but this is now the combined function. Actually, this is also a vector, but it has only one element. The variable is a vector, only that it has only one element. Now the combined function here is used when we have more than one element. So suppose I have this vector y, and I'm trying to store elements of different data types. So let's say I have 56. Okay, let's say I want to store early and the age, like that. So I'll say early and then put a comma and then say the age is 22. So when I run that, R will give an error, and it will say the object early is not found. And the reason as to why early is not found, is telling us early is not found, is that we have different data types. And more so, early is not numeric, it is a string. So it will not actually be able to store early as it is like that. Now again, let's go ahead and now have it in the double quotation and see what will happen. So when we run that, now my vector y is taking the value early and 22. So when I run y, it is giving me a value, or rather it is giving me the values early and 22. Now what you can notice here is that, the 22 here is also in quotation, meaning it is taking this 22 as a character, not a numerical value anymore. So by default, R will take one of the data type and make it for all the elements that are there. For all the elements that are there. That is what will happen. That is what will happen when we use R to create a vector of different data type. It will automatically assign it to one data type. Now realize here we were creating a vector X, and this vector X is having elements from 1 to 6. Now for that case, we can say that these elements are actually continuous in nature because they are from 1 to 6. So it is like a sequence, 1, 2, 3, 4, 5, increasing by 1. So to create a vector based on a sequence of numbers, we can make it simple by using operator. By using an operator. And the operator we are going to use here is the full colon, this operator. This operator now to create a sequence of vector. A sequence of vector. We will use that operator to create a sequence of vector. Like, we want to create the vector now. Let's say we call the vector let's say like capital X, because we've never used capital X. So, and we are assigning values. We want capital X to take values from 1 now to 6. So it will take values 1, 2. We are using that operator 6, and we click enter. So when I call for X, X now will be 1, 2, 6, those values. So instead of us writing 1, 2 to 6, we can use that operator. And this is useful more so when you have a very long data set that is in sequence in nature. So we can say Y is the vector of elements starting from 1 to 100. See, such a big number. When writing 1 to 100 will take us a lot of time. But when I use that operator, now I call Y, I already have my values from 1 to 100. I have 1 to 100. Now, these vectors are actually useful in real life when it comes to data entry in R. Suppose you are given a data, maybe the height and the weight of individual is measured, and we want to determine if there is any relationship between the height and the weight of individuals. Now, the first thing, before you even try to determine the type of analysis you're going to do, you need to have your data in R. So suppose maybe there are very few observations, like let's say there are only 10 observations, only 10 people who are interviewed for that matter, and you want to enter that data into R. This is, of course, there are better ways, but this is one of the ways that you can do. Like, we can say the height, let's say the height, or I can even represent it with an H, but okay, the height of the individual is a vector. So now I'll be listing 1 to the last. So maybe the other one was 25, I don't know, in feet, 56, 89, 30, 50, and all that. So when I call now height, I have my height stored. Now again, I'll have the weight as another variable. Now maybe the weight now is 89 kgs, 56 kgs, 78 kgs, 36 kgs, and maybe 70. So you see, now I have my weight as well. so that when I call weight, and you realize that when you write a vector or even a variable, once you start writing, it will pop up like that, and it will have that the icon of that color. You see, a function is not this blue or what, but it is like, is it light red or yellow? I don't know colors. So you can just click enter to mean you are selecting that, and when you run, you have it. When you run, you have it. So it is very practical, this one, vectors. Now, still under vectors, we were saying that we can generate vectors in sequence, and one of the ways we were saying is to use this operator for vectors that are in sequence in nature, and more so in this case, they are increasing by 1. You can see they are increasing in that order, and they are all integers. Now, if you want to create a vector that is not limited to integer and increases by 1 at the same time, we can still do that, because you see here it is an integer 1 to 6. Here we have 1 to 100. What about if they are decimals and now they are increasing by a certain value? Let's say maybe they are starting at let's say 2.5 to maybe 10.5, and they are increasing by 0.1. How do you do that? How do you create such a vector? Maybe I've been looking at that data set, and I am observing from that data set, it is starting from 1.5 and it is increasing by 0.1, and it is ending at maybe 8.4. How am I going to create that sequence without me having to type all that? Now we have a function that can actually generate a sequence, and that function is the sequence function, which is SQ, like that. That will generate a sequence, or rather is called a sequence generation function, and it is under base R. The package where this function resides is the base R package, and you can see it is even giving a documentation. So when I select that function, I can now implement. Now, one thing that I showed you yesterday that will help you to learn R is the help. So if I put a question mark there, I'll have the documentation here of how I can actually implement the function. So you see the sequence, and they say the sequence is starting from and to the last value, and by increasing by what value, and all that. So that is one way it can help you to learn. So suppose we have a sequence. and we want to generate this as a vector now. So our sequence is from where now it is starting from. So we can say from, let's say 1.5, then you put a comma, of course, then 2. Now the final value to, let's say 8.5, and now it is increasing by 0.1. Now when I run that, it will give me all those values. So I have 1.5, 1.6, all the way. It is increasing by 0.1. Now we need to assign this to a variable, this vector to a variable. So I can call this S. So that when I now call S, now you see it is now stored here S. But initially without the S, without assigning the name to the variable, it is not stored anywhere. So when I call now S, it will give me that. So, but the beauty of assigning it to a variable is that you can call the variable and do your analysis. Now you realize, actually, I don't have to write all this. I don't have to write all this, because we know how the function, the prototype of the function, like how the function flows, how it looks like. We start with from to by. So R actually knows that. So actually, to make work easier, I can actually have this function this way. I can say R is equals to the sequence of this value starting from 1.5 to 8. No, let me just change to 7.5 so that we can see the difference, though there is the same thing. Now, and it is increasing by 0.1. There is a name for this kind of arguments that are passed in that order. There is a name for that. The name doesn't really come in my mind. Now, you see the order of the arguments. We are just passing the values as they are. So R knows that 1.5 is where the sequence is starting, and 7.5 is where it is ending, and 0.1 is the increment. So when I run that and I call S, now you realize S will be those values, 1.5 increasing by 1 to 7.5 to 7.5 to 7.5. So that is another function that will be commonly used when generating vectors, the sequence function. Also, we have other functions that we can use apart from the sequence function, like the duplicate function. Now, this duplicate function will replicate elements of a vector and also in lists. We look at what a list is. It will basically repeat the same value based on a given number of times. So when we select that function, again, to help you learn more, you can check the documentation. You can check the documentation of the function, and you can see we have x and the number of times it is to be repeated or replicated. So I can say, suppose I want a sequence of my name, my name. Let's say I want to write Ali, and I want Ali to be repeated 10 times. So you can write, actually here you can write times, equal to 10. Times equal to 10. You see, x is the value, then times equal to 10. And when I run that, it is giving me Ali 10 times. So the duplicate function will replicate a single value based on a number of times that you would have specified. Based on the number of times that you would have specified. Now you realize at times you can even be combining these various. You see the way we're creating vectors. We were using the concatenating here. We were using the concatenating. Then we were using this operator to have a sequence of values. Then again, we were at one point, we were using the sequence to generate the sequence function to generate the vector. And now we are using the duplicate function to repeat the same thing. Right? I mean, repeat a single value based on a number of times. So we can at times combine these various ways to create one vector. And this is commonly used. It is commonly used. For instance, I can say I have a vector, let's call this vector P, and this vector P is actually the combination of, you see I'm starting with the combination, the first one we were using, the combination of the repetition of, it is a combination of a repetition of, I think that I'm making things complicated. So it is a combination of the repetition of the sequence, it's getting sweeter now, of the sequence. Now, a sequence of what? A sequence of numbers starting from 1, ending at 9, increasing by 2. Are you seeing that? So, what will happen first is that it will create this sequence 1 to 9, and it is increasing by 2. And then it is now to repeat this sequence. It is now to repeat this sequence. How many times? So out of that, I'll put a comma and say repeat it 3 times. Repeat it 3 times. So that is now my first element for the combined function. For the combined function. Is this C a capital C? Should be a small c of my combined function. That is the first element. Now the second element I can say is now a combination of, now I'm using the combined function inside a combined function. The combination of 1, 2, 3. 1, 2, 3. Now I put a comma. There is now another element. And I can have another element as 42. There is one single element. And I can have other 2 elements or 3 elements as, let's say, one that are not there. I can say now 2 to, let's say, 4. 2 to 4. 2 to 4. And then I run this. So when I call P, it is giving me those values. It is giving me those values. I don't know if guys you can try to analyze the output. Now this is what is happening. The first element is this one. The first 3 elements are this. And why is that? Because inside for the first element, we have this sequence which is generating numbers from 1 to 9 and is increasing by 2. So we have 1, 3, 5, 7, 9. That is the sequence that is being generated. But then we are repeating that 3 times. So I have 1, this one here, then 2, then 3. It's repeated 3 times. Then after that, I have 1, 2, 3 as the other element. So these are the 1, 2, 3 here. And then I have 42 as another element of the vector, which is here. And then I have 2 to 4. So 2 to 4 is 2, 3, and 4. The last one here. That is how you can combine the various ways so that you can come up with a vector. A vector. Now you realize one important thing is, at times we want to know the length of the vector. I mean, what is the number of observation in those vectors? The total number of observation. Now to look at, or rather to check the total number of observation, we use what we call the length function. So the length function will give us the number of observation of the vectors, or rather the length of the vector when we use the length function. So suppose I want to say the length of height. So let's just say height, the length of height. And it is that height. So when I run, it will tell me 5. So literally, there are 5 observations in the height. There are 5 observations in height. There are 5 observations in height. Guys, at that point, are we together? are we communicating? If you understand, kindly type 1, and if you are not, kindly type 0. If you have any question, kindly raise your hand. Yes, I'm seeing Saif is saying 1. Amina 1. Mary 1. Okay, because we want to be on the same page, let me also type 1. Why should I leave me? Am I the odd one out? So 1 also. So yes, that is now how we create a vector. Now, one thing that we need to finish when it comes to vector is what we call subsetting a vector. Subsetting a vector is like, I want to get a portion of the vector, or rather, I want to access elements of a vector. Like suppose in this height, I want to get the second observation and maybe use it somewhere. So you don't need the entire vector. Yes, in your recording, you recorded the entire observation, but maybe you want the last 2. Maybe you want the middle one and is 89. So how do you get that? How do you subset a vector? How do you get the elements of a vector? Now to subset a vector, we use a square bracket. This is the bracket I'm talking about. So I can say here, subsetting a vector. So we use the square bracket. This is the bracket I'm talking about. So suppose I want to get an observation. First, I need to get the name of that vector. Like for instance, okay, let's just use these examples that are here. Suppose I want to get the first observation of weight. So I'll have the name. I'll need to have the name of the vector. Let's say weight. And then in a square bracket, the position of that element that you want to access or rather subset from that vector. So when I write 1, I'm expecting this to be the first observation, and it is giving me 25. So when I say weight, 3, this will give me the third observation. That is 78. Now what about when I want to get the first to the third observation? Now there are several ways. I can write weight. And you say from the first to, now we use that operator, the third. Weight from the first to the third, and it will give me the first 2. 3. Similarly, because weight has okay, let me not use that first. Suppose I want now from the first one to the fourth, because they are 5. Let me just start by saying that. So I want from the first to the fourth. So I'll say weight from 1 to 4, and I click enter. So 1 is the index of that element, the position rather of that element. 1, 2, 3, the position of that observation. Now realize there are also an alternative that I can do all of this actually. Look at the last one, for instance. Weight from the first to the fourth, and there are only 5 observations, which means I'm only excluding the last one. So another way of getting this is actually to say I need everything for weight except the last one. So I'll say weight. Now in that square bracket, I'll say minus the last one, that is the 5th. And when I click enter, it is to give me the last one. Okay, it's wait. A problem with the name wait, and when I run that, it will give me except for the last one. It will give me except for the last one. Now look at the second, this one here. Wait from the 1st to the 3rd. So we are looking at the 1st, the 2nd, and the 3rd, leaving the last 2. So it is leaving the 4th and the 5th. It is leaving the 4th and the 5th. So I can say, there are several ways you can write that. I can say wait. Now wait, but now for wait, we are leaving the 4th and the 5th. So I can say, when we say, this is the mistake, when we say minus the 4th, comma minus the 5th, and we run that, it will bring an error. The reason as to why is that these ones are 2, and because they are 2, we need to use what we combine, a combined function. So when you run that now, it will minus the 2. So whenever you're trying to do something that involves more than one element, the aspect of combined function will always have to be applied. Like for this case here, you can see this case here. We are saying 1 to the 1st one to the 3rd. This one here. That one can also be written as wait. Now now we are using a combined function. Instead of saying 1 to 3, you can list them one by one. 1, 2, 3. And you will have them as well. So there are several ways of accessing or rather subsetting a vector, the elements of a vector. And one last is that we can use what we call the logic values. So when I say for the first element true, it means I want it to appear. Then I say false, I don't want that. True, it means it will appear and all that. So because here there are 5 elements, here, what I'll do, I'll first create a vector. Let's say I'm creating a vector W, and this vector W is made up of 5 logic tests. The logic values. So I use the concatenating function. And say for the first one is true. The second one is false. The third one is false. Is false. The fourth one is true. By the way, you can just write T and F R understands, and the last one is also true. So those are the 5, and I run that vector. Now, suppose I want to get the elements of weight such that I want to get the 1st, the 4th, and the 5th. So I don't want these ones here. That is why I'm putting them false. So I can use this logic to get them by writing the name of that vector, weight. Then in the square bracket, now I pass the vector that I've created, the logic vector. So when you run that, you realize you only have 89, the first one, 35, the 4th, and 70, the 5th. And we can confirm this. 89, 35, and 70. So this is true because we're putting them to be false. they'll not appear. So there are several ways that you can actually subset a vector. There are several ways that you can actually subset a vector. I don't know if that is clear to all of us. So if you understand on how to subset or rather accessing the elements of a vector, kindly type 1, and if not, kindly type 0. If you need any clarification or you have a question, you can raise your hand. Yes, Mary. Just a minute and then you ask your question. Yes, Mary, you cannot ask.
Okay, suppose the type of data you are storing in our vector is Almax, and maybe they are for 100 students and you want to assess anyone who has scored 50 and there are several 50s. How do you go about that?
Mary is asking, suppose we have stored marks for 100 students, and for this case we want to get the marks of those students, or rather the marks of a student who has scored 50. And there are several 50s. How are you going to do about that? Okay, so I'll take an example here. And say these are our marks, assuming, but now this is weighted. So we want to get 78. But now it is not only one who is having 78. Like we have several people scoring 78. So we want to get that value. I think that is what Mary you are asking, right?
Yes.
Okay. We subset whatever we were doing. We were trying to subset vectors based on their positions. But now Mary has actually reminded me to check at how we can subset vectors based on conditions, or rather based on a condition. Now, one condition is filter elements that are equal to a certain value. So let's look at this first case. We are saying we are filtering element, or rather filter element or elements equal to a value. Let's say now our case is 78. So we are filtering those elements that are 78. So this is how you do it. Actually, I had done it. I thought you guys are still on the meeting. So we'll say weight. Then instead of having the position, or rather the index in the square bracket, we'll say weight is equivalent to 78. So this will print those values that are only equal to 78. So when I run that, it will give me those values that are equal to 78. Now another thing, maybe just to add on that, we can also filter elements based on, okay, this is one condition already, but maybe one that is less than. Suppose we are saying we want to filter elements that, let's say anybody who is weighing less than 58. I don't know if we have something less than 58. Okay, yeah, we do. So let's say less than 58. We only want that. So we'll say weight. Then on the square bracket, again we say weight less than, the weight is less than 58. So we'll write 58 there. and when we run, it will give us those values that are less than 58. Now, and it is not always that we will have one condition. At times, you can have more than one condition. Suppose we can say that we want to filter. Let's say now here we are filtering. It is always good to have a comment, because as you'll be looking at your code, you'll understand. So filter based on multiple, let's say multiple conditions. Don't bother about the spellings, multiple conditions. So an example is, now here now you can decide how you will formulate your condition. Like suppose I say I want those values from, now this time around let's use height. Those values that are less than 30 or greater than 56. So you see I have two conditions. Okay, the other operators we were to talk about when we were looking on basic programming, but let's just use them. So I'll say height. Now I open the square bracket. Now I'll open, because I have two conditions, I'll open one bracket for the first condition, and I say height, which is less than 30. That is the first condition. Now I need to put or. So now to put or, you use this, is a straight line, not a forward slash or a backward slash. That is the or rather the logic or, and say height. We were saying height greater than 56, and we run that. So we are getting, this one now is based on two conditions, and we are having an or. So it's either the height is less than 30 or it is greater than 56. So the first one, 25, is printed because it is less than 30, and the second one is printed because it is greater than 56. You can also have another condition, two conditions, or even three or more. Like suppose I say when the height is divisible by 2 and greater than 56. So those now is subsetting the elements of vector based on conditions. I don't know if that is answering your question, Mary.
Yes, I'm okay.
Perfect. Thanks for that awesome question. Any other question? So you can also use filter elements not equal to, not equal to, all those conditions. These are now aspects of programming, but they are very important. They are very, very important. Now I think we were actually I was hoping that we'll do the entire data structures, but we have only checked one, and we were supposed to look at matrices, lists, data frames, and all that. That is why I had provided the data, so that towards the end of those data structures, now I show you how we can import our data. You don't know, but I'm still okay. We can do one or two. Maybe one thing that we just finished on vectors. We can do some operation on vectors. We can do some operation on vectors. Like suppose we were having the vector x. Okay, I'll redefine the vector because I don't remember the values that were there. But we were saying, suppose we have the vector x, and this vector x is made up of elements from 1 to 10. From 1 to 10. Now, suppose I say x plus 1. This is now a simple arithmetic. I'm taking that x and I'm adding 1. What is really happening? So because x is a vector, you realize each element or every element in x will be added 1. So the first element is 1, 2 to 10. So we are adding 1. So the first one will be 2. From now 1 plus 1 is 2. The second element is 3. From now 2 plus 1 is 3. And like that. And like that. What about if I take 2, multiply by, now this is how we multiply in R. Multiplication is represented by that star by x. So in simple terms, I'm taking each and every element of x and I'm multiplying by 2. The first thing was to display the values of x. So, I see what is happening. So you can see, okay, which is which now? Okay, these are the values of x. These are the values of x here. So x multiplied by 2, this times this is 2, times this is 4, times 2 is that. So it is adding, it is multiplying those values like that. Now, but this is capital X. That is why I'm seeing the difference. It's supposed to be small x. Yeah, so it is going to 20. Remember we had another value, another variable capital X. Now, suppose now, what else can we do? Okay, I say 2 rise to the power x. This is now quite interesting. 2 rise to the power x. So what is happening? Okay, we are taking 2, now rise to x. But x now are these values. So for the first one, it will be 2 power 1, which is 2. 2 power 2, which is 4. 2 power 3, which is 8. 2 power 4, which is 16, and it proceeds like that. So these are the powers. It is doing one at a time. It is doing one at a time. What about if I find the square root of x? Now it is a vector. The square root of x, and x is a vector. Now basically, it is finding the square root of each and every element. Like the square root of 2, the first one is 1 here. The value of x is 1. For 2 it is this, 3 this one, and 4 of course it is 2, 5 that and all that. And you can see for 9 is 3. We are all sure about this and that. So that is operation of vectors. Now also we can do We can also do the logical now. Actually, Mary asked this question, but we were coming there. The operation. So we can do what we call the logical operation. Now, for the logical operation, we have that vector x, or let's just define another vector altogether. We can say a vector z, yes, and z is of the elements 1, maybe 3, 5, 7, 8, 9. Of course, we don't have a comma for the last element, and we run that. So I can call z so that I can display z. 1, 3, 5, like that. So logic is now based on some test. So I can say for x greater than 3, it will basically pick all those values of x that are greater than 3. But now it will not return the values. It will give me the logic test. It is doing a logic test. So it is coming, oh, I did for x instead of z. So let's just do for z. Now what it is doing is, or what is happening is, for this z, these are the elements. So we are looking at the first element, 1. Is it greater than 3? No, so it's false. 3. Is 3 greater than 3? No, false. 5. Is 5 greater than 3? True. 7. Is 7 greater than 3? True. So you see, this is now what we call the logic operation. It is testing. And now that is very useful when it comes to subsetting, because it is the concept we are using. The same way, the logic test, we can check for x equivalent to 3. X equivalent to 3. And you see we have false, 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 and only true where x is equals to 3. Yeah, the third one here, because the, is it the third? Oh, I'm still using x instead of z, okay? The second one here is 3. Now another operation, now we can also check z not equal to now 3. So z not equal to 3. It is only the second that is false, but the rest are not equal to 3. So at times, or we can combine multiple conditions, like here. But now I want us to use the AND. So let's look for the value of a or z such that z is equivalent to 3 and z, now this says not equal to 3. I know someone is like, well, what is that? So we are looking for those values that they're equivalent to 3. So I'm expecting that this one will be true and for the rest will be false. And those values of z that are not equal to 3. So this will also be false. And now these one are true for the second condition, but they are false for the first condition. So no one is meeting the true condition, both of them. And the only way it can return true is when both the condition holds. So therefore, I'm expecting to give false to root. So when I run that, I have false to root. I have false. Now I want us to do the very same because I want us to see the difference. But now instead of using the AND, we use the OR. We use the OR here, the logic OR. So it's either is equal to 3 or it's not equal to 3. So if it is meeting one of these, then it would return true. And I'm expecting it to return true for all those, because this one is meeting the first, while the remaining are meeting the second. So when I run that, it is true for all. It is true for all. So that is very, very useful when it comes to subsetting. Now another thing, we have functions. Like I have the sum function. Now sum function is one function that is used to sum values or other numbers. It is found in this R. You can ask for help and see the documentation so that you can learn even more. So we can actually use this sum function with a condition. Like I can say sum for Z such that the value you are summing are greater than 3. And I click enter. So what is happening is, it is first testing this logic. So looking at these values, if it is greater than 3, then it will do the sum. So when I run that, control enter, it is giving 4. Someone to tell us why is it giving 4?
I tried.
Yes, Mary.
It's simply because there are only 4 numbers which are greater than 3.
There are only 3 numbers which are greater than 3. Are you saying 3?
No, 4. There are only 4.
Perfect. So it is checking those numbers that are greater than 3 and now count them in simple terms, but not counting. So this one is greater, this one is greater, this one is greater, this one is greater. So it is true. That is 1, 1, 1, making it 4. Now, there is another function that is very, very useful in R. And there are actually a number of them. And one of them is what we call as numeric. So we write as dot numeric. Now you realize this function is useful in that at times we will be importing data, and when we do, some of these values that we will get from that data we are importing are actually numerical in nature, but R didn't recognize them as numeric. So we are trying to convert them to numeric, and we'll be using this function as numeric. Say x greater than 3 as numeric for x greater than 3, and we run that. So what it's doing is converting strings or other characters now to numerical values. So what is happening here is that, or someone can also try tell us what is happening as numeric. Okay, the essence of the question as numeric is it is converting the string arguments, or rather the characters, to numerical value. So what is happening here? When I say as numeric, x is greater than 3. Now remember, this is a logic test. There is another hint I'm giving. So the logic, okay, this is what is happening because of time. As numeric, x greater than 3. Now x greater than 3 is a logic test. that we are using to test, okay, should be Z. Let me just put Z because Z is here with us and we can easily refer. So let me just say Z. Now, it is looking for those values of Z so that they are greater than 3. So if it is greater than 3, we will have true. And if it is not, it is false. So like for the first one, for the first two, we have false, false. And this one is true, true. Now, it is supposed to write false, false, then true, true, true. But now we want the function as numeric is converting that to now numeric. So, false is always coded as 0 and true is 1. So 0 and 1. So this initially, if we were not using as numeric function, so we were just doing it this way, we realize it will give us true, false, like that. So that is the output inside this function, this one here, that is its output. But now, as numeric is converting it to those values now, those values. So the other one that I was saying that is used to check if a value is numeric is now as is.numeric. We are checking if actually it's a numerical value. These are some of the functions we interact with when we're starting on our journey in analytics. Another one is also which is also another one that you can use. As well, you can ask for help and check the documentation if need be. You can check for the documentation, and it's saying it gives true indices of logic object, showing for arrays. So I can say again, which x is greater than 3, which x is greater than 3, greater than 3. So when I run that, it is giving me those values. So what do you think is giving me that? 4, 5, 6, 7, and 10, like that. Someone try that. Now, did I say x again? And I'm comparing, okay, let's say z, so that you can compare. Now this gives the true indices of the logic object. That is what is happening here. So z, which is greater than 3, the indices. Now when we look at 3, then we have 5, 7, 8, and 9. Or actually these ones here. These are the 4 values that are greater than 3. Are the 4 values that are greater than 3. Now instead of returning these values, it will return what we call the logic indices. The logic indices. So there's some computation that is happening behind here. When we run this, we are getting this output. This is what we call the truth values. That is either false and true. But now this case here, what is giving us is what we call the logic indices of these values. So they are always computed. So that is about vectors. All this is under vectors. All this is still under vectors. Now another simple function that we can use as we finish is what we call they are the basic functions. Now assuming, let's just go back and have our vector height. This one here. We have those values there. Still our height is there. So for that. So from that height, maybe you want to get the mean. These are functions that are found in this R. So how do we get the mean? We'll use the function known as mean. So I'll just say mean height. And I have the mean. Suppose I want the median. Still, I'll use that median function. So when I say median height, we will get the median height. The standard deviation, which is SD for standard deviation. So you say standard deviation height, and when you say standard deviation height, you'll get the value. Of the standard deviation. Also variance, var. We use the var. Okay, I'm moving fast because they're basic functions there. So var height, the variance of height, and also these are things we have been talking about. What is mean, what is variance, and we'll still talk more about them. So that is all about vectors so far. We were not actually supposed to cover only one data structure because there are many. So I don't know. I'll still try to negotiate with the members. If we still have a class tomorrow, we will look at matrices, how to create matrices, how to access elements of matrices, just like we are doing in vector subsetting. We'll look at lists and try to get the difference of lists, matrices, and all that. And we will also look at data frames. Now, data frames are very important, very, very important. And I repeat, data frames are very important because the data that you'll always import, it will always be looked at as a data frame. So getting to know how you access the elements of a data frame is very important. And also for lists, of course. At times, you realize you don't need the entire data set. You only need a portion of it to do the analysis. And it becomes a challenge. Now look at that spreadsheet that you have, the Excel spreadsheet that you have. You have imported that to R, and that sheet is having a name, like the one I was sharing is called data. Now in that data, you now have a column called height. You now have another column called weight. You now have another column called gender. So I only want to access height and gender. Or I only want to access height and test it if there is any relationship with gender. So you see, you only need a portion from that spreadsheet, but now it is in R. That is now what we will be discussing when it comes to data frame. And again, after discussing that, we'll go ahead and now do what we call data importation. So we'll import our data now to R, and now from there we'll be able to do some simple statistical computing. But before we look at that, we will now do basic programming, like creating user-defined functions and all that. Now after that, we now start summarizing the data. There is now descriptive analysis and all that. So, any question as far as vectors is concerned? Any question? We actually have to take a lot of time, but it's worth it because I think we have covered almost everything when it comes to vectors. Also, I've shared a video on the channel, on the group, the WhatsApp group. That video, I recorded that video 1 year ago. We have something to do with these data structures. That is why I posted it there. So you can find time and try to watch that instead of watching this. So I'm sure you'll find something I said that I didn't say here. Or you'll find something I was doing it maybe in a long way there, but I'm doing it on using a short way here. or you find another different way altogether. That is the most important thing. So any question, any point that is not clear, or any clarification, or anything that you feel like you want to add, the floor is yours. And if there is no question, then we can stop here today because it's late, and we will continue tomorrow, God willing. So have a good night. Remember to save your work. It is good to save so that at the end of the day you have a R script that you can easily revise and try to see. So don't I'm not saving this, but you save that. It is good to always have it. So good night.